Hello and welcome to Electronics P1 and P2. Two of the fundamental building blocks for the circuit you're going to build for Electronics P1 and P2 are the general purpose diode, that's the one that I've got at the top here, and the Zener diode here. Dealing first with the general purpose diode, the function of a general purpose diode is to allow current to flow in one direction, and that is the direction of the arrow. In order to get a diode to switch on and conduct, we must connect a voltage across it, a positive voltage across it, of between 0.6 and 0.8 of a volt. And that's what I've done here. I've connected a power supply to the positive terminal of the diode, and the negative terminal of the diode is connected to ground, and we've got more than 0.6 of a volt. And from initial conditions, you can see that the diode here is conducting 92 milliamps. What I'm going to do is I'm going to change the voltage to 20 volts, and I want you to note here that the voltage across the diode XMM2 is at about 700 millivolts, give or take. When I re-simulate the circuit, even though I've doubled the voltage, you'll note the voltage across the diode itself, the general purpose diode, is 792 millivolts. It's changed not much at all. And this is a characteristic shared by virtually all diodes. Once we've got them switched on, once they are conducting, the voltage across them will change marginally. A Zener diode is specially constructed to be operated in what's called reverse bias mode. That's where the positive of the supply is connected to the negative of the diode, and the positive of the diode is connected to the negative of the supply. They are supposed to switch on, they're supposed to conduct, but to maintain a voltage across themselves, which in this case, for this particular Zener, is given as 5 volts. There's many different types of Zeners, and they can have different voltages, but this one should maintain 5 volts across itself, regardless of what we do with this power supply here. To show this, I'm going to double the power supply. You'll note the Zener voltage at the moment is at 4.972 volts, and when I simulate the circuit again, you can see quite clearly that it's changed a little, but for a doubling of the supply voltage, just a few millivolts change in the voltage across the Zener is a pretty good result. And that's the purpose of a Zener. It's to provide a stable voltage reference regardless of changes in the power supply. Of course, if the voltage was to drop below 5 volts, the Zener would stop conducting. So we need at least 5 volts to get this one to conduct. But once it's conducting, once it's doing its job, the voltage across it will remain stable at about 5 volts. This makes Zeners very useful in voltages in circuits such as voltage regulators, where we need smooth, stable and regulated power supplies to run things like computers and microcontrollers and logic circuits. And that's what you're going to be dealing with when we're looking at the circuit for electronics P1 and P2, which shows us how we can go from AC to DC to regulated DC. I hope this has been useful, and I look forward to going through the next tutorial.